How are you guys doing today? Well, thanks for coming. The Meetup's changed like ownership a few times, like the Meetup app, and they changed the way they do notifications. So now I get a ping every time somebody signs up. I used to like just get a notification like the day before the event, and so I'd have to check. So now I get a notification every time somebody registers, and it always feels like there's like 500 people registering just because it's like constantly pinging me. But so I never know how many people register, but I'm glad you're all here. So our original speaker, Dallin, no, it's Dylan. No, it was Dallin. Yeah, Dallin Bentley messaged me yesterday that he tested positive for COVID. So you do not get to learn about building an AI data engineer. I'm sorry. He will give his talk later at another time, but I told him not to come if he had COVID. No reason to come. So you get me. I'm Miriah. How long have I been running this meetup? A few years? 4 years? 3 or 4 years? This is a data engineering meetup. What do we have for announcements? If it's your first time here, we have a Slack group. We are part of a group of meetups run by the Forge Utah Foundation. Our Slack can be found at our website, forgeutah.tech. We've got a whole bunch of meetups. We have a Go meetup, and we have Bring Your Own Computer and Build on Stuff meetup. We have an AI meetup. Sometimes we have an engineering leadership meetup. We also like Python at the Point, and all different kinds of events are there. Great tech community, so just forgeutah.tech's our website. Next week is the MLOps meetup that's in Lehigh. They'll be talking about tool calling. So tool calling 101. In 2 weeks is Utah Tech Week. If you have never heard of Utah Tech Week, it's essentially it's a calendar of events. I think the website's utahtechweek.dev or utahtechweek.com. I don't know. But they have events every day of the week, all week, and you just pick the events you want to attend, and you can just go and hang out. They have pitch parties and meetups and all kinds of. There's a Women Tech Council social one of the days that they didn't tell me about. I had to find from the calendar. They should have told me about it because I know everybody that runs that. Yeah, Utah Tech Week's a great thing. And next month, the data engineering meetup will be in Lehigh. We're talking about data governance. I forgot the talk title, but it'll be a talk about data governance. So yeah. Is anybody hiring or looking for a job? I'll open the floor. If anybody's hiring, I'm not hiring. Looking for a job? Nada? You'll need a job eventually? We all will need a job eventually. Eventually, I will also be looking for a job, so currently employed, but I like to change. There is a jobs board in the Forge Slack. There's a jobs channel where people post jobs, and then jobs wanted where we post our resumes. So great, cool stuff. Cool. Oh, Ayla's not here, but we also usually thank Recursion for providing us space and food. But she's upstairs manning the door, helping people come in. Yeah. Cool. Any questions before we get started? Anything else anybody wants to shout out? Awesome. Well, like I said, you guys get me today. And I hope you enjoy it. My little presentation is about using data as a guardrail for agents. I work at School AI. That's my job. So that is my day job. Where did my thingy go? I had a thingy that was like the, I bet it's, there it is. School AA is my day job. I organize this meetup. I also publish most of my stuff on Substack. I do stream software development on Twitch, but my basement is under construction and we're finishing my basement and I currently don't have an office, so I can't stream.
The kitchen table, huh?
Not happening. It's not happening without that. So anyway.
So is that when you stream as you code, or what?
Yes, I live code.
Oh, wow, cool.
Funny thing is ever since I have moved, I've kind of just been doing coding agents. So now I don't know how to code anymore. So it'll be really interesting to see what I stream now. That's just a side note. Anyway, cool. So you get to hear about all of my experiments that I'm doing. Is anybody here working on agentic AI systems? We got one person.
Well, gotta define working on.
Adjacent, using it, I don't care.
Learning about.
Learning about, that's close enough.
Yeah, so I'm a lawyer, kind of getting into AI and stuff.
Yeah.
So I think I might be, but I'm not sure what it means.
So an agent, right? An agent is when the AI does something for you. So anytime the AI performs a task on your behalf, that's an agent, right? And so if you're building a system, right? So you're chaining together more than one kind of a call or automating those kinds of calls. That's building an agentic system, right? I know that, the reason I ask is I know that a lot of times data engineers get like tunneled into this hole of business operations where you're in charge of supporting business and finance and marketing. And you don't always get to work on a lot of the fun, shiny things. Today's talk is definitely all about the fun, shiny. Here's the thing. We have a lot of data. We've been collecting data for lots of times, right? We've got data warehouses with things. Knowledge base is a word that I've seen come up more and more because knowledge is turning into one of those funny keywords that people like to use. Same as like cloud, how cloud was a keyword. And everyone's like, I'm building it on the cloud. Knowledge is turning into that, and it's quite hilarious. It's like, what is knowledge? It's like IT. Knowledge bases, right? So we have things where we essentially have conglomerations of information. Google Drive, Notion, what is the Confluence? Any kind of a wiki would also be considered a knowledge base. Lots of data sets. And how many people would just let AI go touch any of their curated, beautiful data sets? Depending on, you let AI just do whatever it wants to it.
Read only?
No, everybody's going to say read only. I'm also like, as long as it's read only, who cares?
No, we do have some curated data sets.
Yeah.
But it took a lot to get there.
You have lots of curated data sets for AI to use, or just in general, curated data sets for production use.
Yeah, curated data sets for production use that AI is accountable.
That is now, perfect. That is great. Most of the time, you're also doing the new shiny back there, Jake. Most of the time, I see agents, I have not seen a lot of things in the wild where agents do a whole lot interacting with data. I've seen RAG, like a little bit of like semantic search, I think is kind of all I've really seen as far out in the wild. But most of the time it gets widely ignored. But like I said, a lot of these are curated, they have domain experts, and we've spent a lot of time in engineering validating them and making sure there is some amount of accuracy in that information. Like that is like the whole point of data engineering is to validate a minimum amount of accuracy to that data set. So here's the problem with agents. AI can hallucinate. That is, when AI is trained, it is literally like part of its reinforcement learning is it is trained to always provide information. If it doesn't know, it is told to guess, because it is always better to provide some kind of information with an affirmative tone than to say, I don't know. That is how it is trained. And that's why hallucinations occur, is because it is trained to always give information. a good chunk, right? It has such a wide corpus that a lot of the times it can suggest things that are relatively accurate. But sometimes it's not true. I don't know if you're like me, but a lot of the times you sit there, and I've switched from Google search because the Gemini blobs were annoying. And I do almost all of my search with ChatGPT as my search engine. But then I have to get to the point where I say, okay, great. Now, how do I know that you're not lying to me, right? Because like with Google search, it's an immediate redirect. And I can say, this is a valid website or this is an invalid website, just for me, I don't know. I think we had a whole like not semester, but like a section in 8th grade where we had to learn about what makes an internet website okay. So like, right? And so now with AI, how do you validate that it's accurate? What do you guys do when you're asking AI?
Right, you ask itself if it's valid or not, in a way.
I mean, yeah.
What if you ask 2 different ones? See if
You can compare it against itself.
Yeah.
I mean, when I'm doing search, I almost always tell it to cite it. I said, give me a link, or give me a reference, or give me some kind of like third-party information to validate what you've just told me.
Yeah, I guess that's what I meant.
100%, no, I agree, right? Yes, you are asking it for something, but I always ask it to perform that extra step and go get that extra source to validate what I'm saying, right? Guardrails, right, like they just kind of act on their own. And autonomous agents, right, this new thing where we've just decided, okay, we're just going to let the agents go. I don't know. Anthropic posted a paper where they're like, great, we have found agents do a better job when they define, like when they tell us when they're done. Like, so they'll let the agent continue to iterate through a task until the agent has determined it has completed that task. So like when you're doing coding, right, it's not just generating code in one pass. It's usually doing 5 or 6 passes of creating code until it's decided what the final pass of that code is, and then it presents it to you and says, this is what I've come up with. I've determined this is valid code. So that's like, we've gone to a more autonomous route because we find that they can self-validate within a certain bounded context. And a lot of the ways that we have in the past provided, right, we have to provide guardrails still, or else hallucination comes in, right? So like with coding, a lot of the bounded context comes from the prompt that says you're a coding agent, you can do this, you can't do this. And those are just system prompt style guardrails. If you've ever looked at like OpenCode's system prompt or some of the leaked Claude Code system prompts, they like to have capitalized letters. Critical, must. Those things are very common in systems, and the AI does respond to keywords like critical or warning. They respond to capital letters and saying that's important, right? That's what it was trained on. It was trained on corpuses like that. So system prompt guardrails are how most guardrails work right now. The problem is, what happens when you have a 2,000 token system prompt, right? And your token window is 30,000. Now your system prompt's going to always take on most of the space for the iterating. So the more information you add to the other thing, I don't know if, has any of you ever had rules in your system prompt that got ignored? Right? So I've had that same thing, right? I'll put something in my system prompt, big bold letters, critical, must do that. You're going through your chat, 50 steps later, it completely ignores the original system prompt, right? Because relevance does matter to the original thing. So the more information you add after that initial system prompt, the less reliable those rules are to be followed. So the guardrails in the system prompt are fine for small bounded context windows. They don't scale, they're not infinite. And the more data you add, the weaker those guardrails become. Has anybody tried doing just injecting data, information, throwing information at the AI?
Through tools, yeah.
Through tool calls?
Yeah.
Okay, that's the smart way to do it. I have seen one of the things that I've seen people do is they'll just query a database, take the rows, and just inject that, right? Just it'll be like, okay, great. Here is some data. Tell me what it means. Or there'll be something like, okay, great. Here's 100. Well, actually, how many rows do we give them at work? It's like 300 rows, 500 rows of information. and then after that, we tell it to do something. So it has to process all of those roles, put information in them, and it doesn't always get a good, raw data does not have good information. It just sees rows. It doesn't know what category means. It doesn't know what a product is.
So,
It's
you said to do it through tools, what does that mean?
we'll get tool calling. Tool calling is, have you heard of MCP?
Yes.
Right? So MCP is a protocol around tool calling. So what a tool call does is it allows you to inject context to the kind of information it fetches, right? So it's a bounded way to give information. We'll dive into that a little bit more, but essentially, tool calling is a great way to give an agent information with the necessary context for it to act on it. Data without semantics is just noise, right? This was just noise, essentially. It was just more information for it to grok. It couldn't get anything. Semantics is the way we give information to an LLM, right? Semantics is how we communicate with each other. Bill Inman wrote a really great blog post, published it on Monday. He's been doing a whole series on text data and ontologies and stuff like that. Bill Inman wrote the original white paper in 1975 on the data warehouse. So, father of the data warehouse, great guy. I shook his hand once. He was talking about unstructured text specifically. He's right. So we have this entity relationship diagram, which is a data model, which is how we have defined our data warehouses. We've defined our databases, and that is how we as engineers can reason about what data means and how it relates to each other. Now we have to do that with text, right? The way to do that, the way to inject semantic meaning into our data to model unstructured text is with an ontology. And that's essentially a fancy way of, an ontology is the schema, the ERD, for that. And we can use it to define references and inference rules. So what's an ontology? It's essentially, it's a way to define relationships. So this is an example of an ontology, right? We have an animal, we have subcategories of animals, and then we have relationships inside there. So we know that a dog barks, has fur, and is a pet. That is a relationship. Well, technically, this is a taxonomical organization of it. That doesn't matter as much. But the way I've been thinking about ontologies, it's a way of modeling data with some kind of semantical meaning, right? A mammal is an animal, a dog is a mammal, and we know that a dog barks, has fur, and is a pet, right? That's essentially a sentence right there in data. And that's how it's modeled and traversed that way. Very similar to a data model. There's just a slight bit more of relationship information that you put in there. Those relationships, you can use these as ontologies are typically organized as knowledge graphs, so they do have nodes and edges, where the node is the entity and the edge is that relationship, and the edge is where that semantical information is stored, right? Like a dog can bark, a dog has fur. The has is the relationship there. And we've all interacted with ontologies and knowledge graphs for decades. A lot of people have thought of semantic search as the vehicle of web search. No, knowledge graphs. BERT is the embedding that we use, right, for that, but it actually is traversing a knowledge graph. How we do that. Taxonomies is how Amazon categorizes its products, right? You'll go to the Bose page, and then inside the Bose page, you'll have speakers and headphones, and inside headphones, you'll have like the 3 different models, and then inside the 3 different models, you'll have 3 different versions. That's a taxonomical, right? Because it's hierarchical organization, and the nodes define that relationship. Medical systems for classification, also ontologies. So again, ontology is a way for modeling text data where the relationships are just words. Human language that we use to describe how one thing is another. This is a subcategory. That's a relationship that we describe into words. The one thing I was talking to Jessica Talisman, she literally, her whole job right now is talking about ontologies. The one thing that I thought was really cool about an ontology that she said is you can make an inference on an ontology. And I always think of inferences with AI, right? So an inference is when you get information from a machine learning model, right? Whether it's classically trained or AI, the point at which you get information is called an inference. And you can also inference technically you can inference off a database with a SQL query. So you would use a different semantic query. Well, actually, there's still a query language, it's just not SQL. Well, actually, it can be SQL that's neither here nor there. You can inference off of them. But the way you inference off of them is by narrowing down your categories to the thing you want, right? So like with a Google search, if you were wanting to say, tell me the top 10 restaurants in the state of Utah, you're going to have state of Utah, you're going to have then restaurants, then you're going to have a rating, and those are all some kind of traverse that knowledge graph would make that we would also as humans make as we're trying to classify something. And that's how the inference takes place, that whittling down of things through that knowledge graph. Traversing a hierarchy, inferring certain kinds of relationships, like this is a characteristic of, or this is a subclass of, like, it's really hard to not think of like the genome, the animal classifications with like the genus and whatever, and you have mammals and cats have like different types, and you have big cats and little cats, and all, you go all those, like essentially finding the way down is an inference. Sorry, I wrote this talk this morning, so I'm sorry it's unpracticed. So back to guardrails, now that I've introduced an ontology, right? We have prompt engineering that's fragile. Output filtering is another thing that happens, right? That's where we go and say, okay, great. Do you think this is right? Try again and again and again, like we did with the code, right? Does this write me code? Does this look like accurate Python? Okay, great. It's not. Try again. So that's output filtering. And then LLM as a judge, same thing. Agents can do well, but I've been trying to build agents for a long, so I've been, my project since Christmas has been building an agent without a framework, just like raw, self-hosted chaos. And I have gotten into so many infinite loops where it just keeps chugging and chugging and chugging and chugging because of I didn't give it enough information, or I gave it too much information, or the criteria was there, or the tool call was wrong. So anyway, here's the story. So the tool call name was find directories with an S, and it was calling the tool call find directory, singular, for 35 loops. And then it exited. So infinite loops of tool calls happen, and those are all currently how we have in the past had AI kind of correct itself with those guardrails. Now, what I'm saying is that your ontologies, because they are human reasoning, they're semantic reasoning, these can actually be really great guardrails for your AI via essentially a tool call. Because you can do a deterministic validation, you already have those relationships solidified. You can deduce facts from an ontology. That's the whole point of taxonomies, is to be able to deduce a certain kind of fact from those hierarchical relationships. By the way, all of my slides are published to GitHub with the links. There are links to research on this specifically, so I'm not pulling this out of my rear end like I did. You can do logical deduction through an ontology if you have defined that model correctly. You can say, great, I see that a cat is a mammal, a dog is a mammal. They both have fur. I know that dogs need to be bathed. I should assume cats need to be bathed, right? There's those are logical inferences that you can make based on those kinds of those things, where you don't have to continually retrain and correct your model. And the reasoning's traceable because you created those decision paths in your modeling. So here's the research. So you can essentially have an ontology as a constraint after the fact, where you say, okay, great, AI, you ask the AI a question, something like, tell me the largest attended World's Fair in world history. And then it can go search the Wikidata ontology, which is downloadable, by the way. All of Wikipedia is stored as an ontology you can just download. And you can have now that the AI can guess something, and then you can go search World's Fairs year, attendance year, city. And you'll be able to traverse that through your ontology, validate it, say, no, that was wrong, this is actually correct. Will you tell me a little bit more about the World's Fair that took place in XY, on this date in this city during this time? So it can then continue off of that. Ontology as context engineering. Context engineering is a fun new term. I don't know how widely adopted it is, but I applied to speak at a conference where they said, tell me about context engineering, so I figured it was cool to throw it in this talk. That's when you use retrieval, like RAG, retrieval on your ontology beforehand, right? So you know something about what you want to do, so you'll go ahead and do your retrieval, do your query programmatically, get that information out, and then inject that validated query information into the system prompt or a secondary set of information on that thing, right? So you could be doing the same thing. Tell me about the World's Fair that took place in Chicago, and then have the ontology go and search random facts about it because it has the Wikipedia thing, right? It went and you found the World's Fair took place in Chicago. You found the date, which was what, like 1894. You found the amount of people. You found this big attractions or whatever that were all in that ontology. Throw that into your context, and now your AI can then format that and have that chat interaction with the user like they would have for that. Or you can do ontology behind a tool call. We talked about tool calls a little bit, right? So that's when you essentially abstract the queries behind an operation that the agent can then take, right? So the agent might be able to say, great, I have been trained and my system prompt has told me everything I need to know about NCAA football. But I have an ontology, great, of Wikipedia, and this person came and asked me about the Super Bowl. I don't know, I know a little bit about football. I know a lot of the rules, but I don't know who won the Super Bowl. But I can make that tool call to the ontology of Wikipedia and see the list of Super Bowl winners and throw that in there as part of my response. Go ahead.
Now, context graphs are like the hotness right now.
Yes.
So as you think about like how to define, like if you can define the models right, the AI can be really smart.
That's the point, yeah.
Yeah, and so it's like, just so everybody, like an investor just called it $1 trillion opportunity.
Yes, but
Context graph, but yeah.
if you talk to an ontology scientist, they'll tell you they don't like the term context graph. I literally talked to an ontology scientist about context graphs. They're really great. It's a way, again, of modeling how data relates semantically, which is the whole point of an ontology.
So are we just building essentially graph databases inside of graph databases?
No, the graph database is not something I want to attach to the information because you can store ontologies, graphs,
As text.
anyway. You can store it as RDF files, you can store it as turtle files, you can store it as SQL in a relational database as long as you have those relationships appropriately modeled in a way that contains that semantic information, right? You can store it as a Neo4j database. That's also possible if you prefer that. It just depends on how you're going to have query optimization, you're going to have modeling overhead, you're going to have however you want to do that. I do not care about the data store. I care more about the ontology as a method of modeling data than I care about how you store it. Go ahead, you had a question?
Yeah. What's your take on RAG versus tool calling?
RAG, okay, great. Retrieval augmented generation. My personal definition of that is anytime you do a lookup to any place, you've done a retrieval. And as soon as you've given that information to an AI, you've augmented the generation that takes place. Now, semantic search, the traditional application associated to RAG, is a comparison. Does this match within a certain threshold? That's great for lookups, and it's great for saying, does this match? What it doesn't do is it doesn't extend that relationship beyond the match, right? Which is essentially what we can do here with inferencing and navigating those syntax trees or in the relationships. Semantic search, I do use, like, I think FAQs are a great use of semantic search, right? Somebody asks a question, is that question similar to this question? Return canned answer. Like, that's how I love semantic search. It's a really efficient and effective way to do word similarity comparisons. But what I'm saying, where it falls short is taking that next step. How do I extend beyond similarity in actual word context to relationships mapped beyond that? Like, cat and dog are both mammals, but semantic search doesn't show us that. It shows us that they are not the same thing. So it's way beyond it. But again, like I said, as far as anytime you do a tool call to access an external source, you have I don't know, is it etymology? Like by like the what retrieval, you have done some kind of augmentation through retrieval. So I think the word RAG will continue to evolve as to what it means. That's why I make the differentiation between vector search and semantic similarity over any kind of traversal of a semantic model. Did that answer your question, or did I just go off on a tangent?
So are you differentiating between, like, the model gets the prompt and then it makes a tool call that does a search on the graph versus like before the model even sees the prompt, you're doing some vector search?
Exactly. Yeah, I'm saying the tool call would happen after the graph. Well, I mean, you can do some stuff before. So like in the context engineering, you would do the traversal of the graph prior to giving that information. The way I have been applying it was through tool calling. Just because I have seen tool calling be very powerful in allowing AI to automate things. That's it. Like, it's just for automation. I find it to be very powerful. It also, the way I've been doing lots of tool calling. I've been trying to write a background code writing job. If anybody has used cursor background jobs or Claude Code on the web, where you just give it a prompt and it like builds you a whole thing, I'm trying to write that, but like with a locally hosted model, like with Ollama on my Mac. I don't care if it takes 5 hours. I can essentially the thing is I could be like, okay, great, I'm on an airplane. I don't have Wi-Fi, but I have my computer and Ollama, and it's a 7-hour flight. I'm sure this could figure something out in 20 minutes, kind of a situation. So with that, right, you can give it several different kinds of tools. You can give it like a grep tool, a bash tool, different kinds of tools that do different kinds of operations, and you let the AI choose which kind of tool. The value with tool calling with this is then I can do different kinds of searches or queries behind each tool call. So I'm still having this kind of governance or definition or programming on what data is being accessed and how it's being accessed, right? It's just, I'm letting the AI choose when that's getting accessed. So that's why I prefer tool calls.
Yeah, so our company also, we had like a RAG system and then we just replaced it with tool calling.
Yes.
Because it just
It's
made our system simpler, and then, yeah, the model can just spec
100%.
context. So I was thinking, like, is there ever a reason to choose RAG versus?
I would say it would be faster to do one operation over many operations. Again, and it's all going to be dependent on context. If you know for a fact that it is doing some kind of operation where it only needs to look up this one thing, then yes, I would do that beforehand. I don't know how often that's going to be the case. And I've often, when I've been experimenting with my tool calls, like a good chunk of the time, it knows pretty quickly what tool calls to use. It's not just like randomly, depending on how you define the tool call, it's all about the information you present it, so. Cool. One more, yeah.
Do you have examples? Are there like leading ontologies
Yes, there are leading ontologies that you can just download. Depending on your use case, like I said, Wikidata is a good one. If you're trying to do if you're trying to do people relationships like social media, there's friend to friend. There's a Berlin data set if you're trying to do an ontology for literal grammars, like you want it to use correct English. Like there's actually ways to model how English sentences are formed, and you can pull that out of there. These are all RDF files or OWL files. Which stands for Online Web Language, OWL, which is how Google search originally worked, was those kind of files. That you can just download and you can populate essentially in your Neo4j database or in your, there's lots of different places that will store RDF files and serve them up behind API endpoints that you can just query. So like you do not have to create this unless you have some kind of domain specific data, and then you would want to model your own ontology. And there are people that have been doing that for years. They're called natural language professionals, NLP research scientists. If you want to hire one of them, if not, yes, there's hundreds, thousands of ontologies you can just download and use. Where things are like I promise you, the first thing we are going to put into production is the Wikidata. Because Wikipedia is amazing, and if nothing else, it has a link at the bottom we can send somewhere else, right? This is a tool call where essentially I'm doing a graph. This is a triple. A triple is a way to define a relationship in RDF, which is just subject, predicate, object. That is the relationship. So I've been modeling everything as triples when I've been doing my own personal model. This can be limiting in ways that a typical knowledge graph or graph database is not, where you can continue to extend that. But a way I really like, the reason I like the triples is it is tight semantic. The word that came to my mind was situation, but a semantic situation sounds way too informal. It's a semantic pattern that is really easy to hand off to the LLM. That's why I really like it. So you can do an assertion, you can do a query on it, and then see, right, we just run the query after we've created the triple. It's a tool call where it's essentially, it just has a validate situation. So it's just validating some kind of assertion based on that triple. And so then when you put it into an agent, you would just run the validate on that ontology, say this is valid based on this ontology. It goes through, so that would be the tool call after the fact when you're going through your things. If the agent needs to, again, say, great, I know everything about NCAA football, but I need to look up this thing that I decided to say about the Super Bowl. That'd be great. A procedural knowledge ontology is really fun. There is a PKO. That blue link is the link to the PKO research paper. And this is something I've been experimenting on with Professor Pedro. All of my side projects have Pedro as the keyword. The reason being my handle online is Soy Pete. And so if you can get the juxtaposition of I am Pedro, that's why everything is Pedro. So Professor Pedro is a tool for learning to code. So I'm using PKO as a way of modeling courses, the course material needed to accomplish that learning of code task. So PKO is a way of modeling procedures or tasks that an AI can accomplish. So you have a procedure, right? So the procedure would be learn to code. The agent, so again, like I said, everything's a model. The reason I like PKO is because it has a really strong model for interacting with agents. And the reason is they have certain kinds of entities. You have the procedure, which is the task you're trying to accomplish, right? Learn to code. You have the steps in the procedure, which would be the lessons. And then the exercises are subsets of the So, and then as part of the lesson, you would have, this is the lecture portion. This is the coding exercise. This is the whatever. You have the agent, which is the person that is trying to accomplish it. And then you have the things related to the information needed for each step. So it essentially builds in those nodes and relationships in a way that's really easy for me to model. as I'm building agents, so that it can do not just assertions, but essentially it helps me have all of the information I need to complete the agentic process. And there I have, again, that code is online where I have it built in. It's not very well tested, but it is built to be able to agentically learn how to code. You write the code. The agent isn't building code for you, but the data is modeled in a way to help through that procedure. Go ahead.
Can you go back like 2 slides on the validation, the ontological validation? So would like the LLM output something and then after the fact it's verifying its response against the graph?
Mm-hmm.
Why not like proactively fetch the information, like use a tool call or like transform it into some Cypher query that can just query it?
You can. This morning, this was the example I thought of while I was working out. Typically, when I'm doing this flow, it would pull up things like, okay, great. Pull all of the courses available. Let's present that to the student, and they can choose which courses. Then I'll go, okay, great. Make the tool call to pull all the supplemental information, right? So typically I'm having it doing a fetch and presenting information more than I'm having it validate an accuracy of something. But if you want to do an ontology as a guardrail specifically, then it would be some kind of a validation action to something that's already been created. It depends on your workflow. Some workflow, like, and again, it's also like a validation, a single tool call to say this is accurate could be quicker than multiple tool calls to get information needed to process. So it just depends on your workflow. There's lots of options for how you implement. Cool. So this is it. This is why I think ontologies are cool, because ontology inferencing is deterministic, right? We've built those models. It's not like AI, which is probabilistic. It's a deterministic inference. The query will always return the same thing. It's auditable because it's a model. You can audit any data model. That's why we model data, is so we can audit our freaking warehouse, right? If we didn't have a data model, those queries would be a pain to try and figure out what's in our warehouse. And it's domain aware because we're injecting the semantic information into those relationships. So we can build, domain aware is kind of, the other thing too is you have ontologies for domains. Like I said, you can go find an ontology specifically for people relationships, and you can find ontologies for medical relationships. You can define them. We have taxonomies for all kinds of biological relationships. We've been building taxonomies for years. These are all publicly available, domain-specific ontologies available on the internet that you can just throw into your pipeline and have an AI reference over. So if you want to be like me and build your own, first thing you need a vocabulary with conceptual model. Jake gave a talk on conceptual modeling a while back, right? That's still the same thing. Find your relationships. What are your branches going to be? You want those to be as repeatable as possible, so that you have certain kinds of patterns, right? That's why you get the hierarchical taxonomies. I've been using SparkQL. That's currently. If you're using Node, Neo4j, you'll use Cypher queries. RDF, you can query with SparkQL. That's why. Just throw it in an agent and see what it does. I've been having a lot of fun with agents doing tool calls on ontologies. It's been doing really well for me. The hardest part is creating the ontology because conceptual modeling is tedious. That's why Jake gave the talk on that, not me. But yeah, that's essentially, I think data engineers can contribute a lot more to agentic systems because we have such a vast amount of validated data that we do not have to use in refinement training, right? Refinement training is expensive, and that's how people have always wanted to do, like SLMs, or a lot of people want to do like medical specific AI, and I'm like, okay, great. We can do a lot of refinement training, or we can just slap a data store on top of it that has all of these relationships defined and do a tool call. It's a lot cheaper. It's just as accurate, if not more accurate. It can be just as fast. We don't need it to be slow, especially with ontologies. You can shrink the size of your model down. Use smaller parameter models, which are much quicker at reasoning if you use a quantized model. And then you can be a data engineer that does AI instead of a data engineer that only does business information. So does anybody have, this is literally, you just got my brainchild, the thing I've been working on for the past 3 months.
I'm glad that you were spurred to write it down. You know?
Oh, you mean when you're glad that Dallin called in sick this morning?
Well, I mean, you were forced to, right? Like,
Yeah, no, I have it written down, but I haven't ever, yeah.
the time.
Yes, no, we've been doing a lot of ontology stuff. Ever since I started this current job, ontology has been hammered into me as that's what we need to get out of our data platform, is some kind of an ontology. And so I've been trying to figure out how to use it with agents ever since. And I've talked to a lot of people and done a lot of research, and Bill Inman decided to go in and write his article, and so it's all been fun. And hopefully you can all learn to code with Professor Pedro at some point and see it in action. If not, you can just go look at it. It's great. But yeah, do you have any other questions? Go ahead.
How do we look at Professor Pedro?
So you see that link right there, my link tree? My GitHub's on that link. It's just on my GitHub. This talk is also on everything's on my GitHub. So
Are you Soy Pete
I am Soy Pete.
at GitHub too?
It's not Soy Pete. It's just Soy Pete on GitHub, not Soy Pete Tech. Thanks for coming.
Thank you guys.
Tech is the incorporation of Soy Pete after the fact. So the business is Soy Pete Tech, but I've been Soy Pete since I got GitHub several years ago, if that makes sense. Cool. There's more references on here. Feel free to read them. The RAG, they're calling it ontology augmented generation as opposed to retrieval, and I think that's stupid. It's still a retrieval action. Ontology guided extraction, graph constrained reasoning, that is the one where it's like ontology as a guardrail, validating against the ontology. These are all really good. Bill Inman's, everybody should read anytime Bill Inman talks about text, you should pay attention, because I don't know what he's done, but it's incredible. Yeah, cool. Are we it?